welcome to this series of learning Haskell for Dummies. I'm making this because I'm trying to demonstrate that Haskell isn't really as hard as people try and make out. By no means I've not got a computer science degree. I'm not a mathematician. I'm definitely part of the Dummies, so hopefully people will be able to relate to this and learn a little bit of Haskell. Right, so what we're going to do is I'm going to be using as a basis this great book called Haskell Programming from First Principles. And if you look, okay, so it's $59. I'll link this in the description. So it's Haskell book and anything else that we're going to talk about. So it's $59 and it's a great book. It's written by Christopher Allen and Julie Morrow-Nuki, I think. Nuki. Sorry, Julie, I don't know how to pronounce your surname. And the basis of this book was that Christopher was teaching Julie how to do Haskell. She didn't actually have any sort of background in programming, full stop. So she learned, Haskell as her first language. What we'll do is we won't go, chapter by chapter, each section, because I still want people to be able to use the book to learn themselves. But we'll take little bits from it. And either if it's a task or something like that, we'll go through it. And then hopefully you'll be able to, in your own time, either use a book or go over the videos. I'm trying to explain bits that might not be so easy to explain in literature. And sometimes it's a little bit easier just to see people coding and explain that. So what we'll do today is we'll try and get things set up. So you're set up with Haskell and you can just get things running, and you'll be able to work with a REPL, which I'll explain what that does. So firstly, I'm going to use a build tool called Stack for the GHC, which is the compiler for Haskell. This is much like, if you go into JavaScript, you've got different types of build tools and package management, and this does that for you in a package. There is another thing called Cabal that a lot of people also use, but I find this, if you're coming in fresh, it's really nice and easy. Again, I'll put this link in, and you go to this and you just simply copy that. I'll copy, and then we'll go to our terminal and you paste it and go. Okay, so I won't do that because I've got it installed, and then that'll get things going. And then from here, now we can start our project. Okay, so now you'll have a stack available, and we'll do stack new, and we'll call this Haskell for Dummies. Okay, and then we'll press enter. Right, so that's made a template. What we'll do here is we'll do Control C, Control P, and add. And I'm not doing optics today, and we're going to use Haskell for Dummies. Here we go. So we'll open that up. So let me see if I can zoom in a little bit in case you can't see it. Here we go. So this is what it generates for us. We're going to have an app folder, which we won't go into for now, but generally this is where it runs our app. That's a Haskell file, the source folder, a test folder, so if we want to run tests, some git ignored, change log, a Cabal file, because Stack still uses Cabal, but it's kind of like a wrapper around it to make things easier, a readme, a setup package. So what we want to look into is this one, package.yaml. Okay, I'll zoom in a little bit. Here I didn't set any of these things, but you can set them up as arguments to that function that I called. So you can set up all your bits. The things that we'll concentrate on in the future, or you'll come across, is here dependencies. So this is any external dependencies that uses. So I guess with a language like JavaScript, it'd be your npm packages. This is where you'd install them in here. So what we can do is we can check those out. There's a sort of a package search, it's called Stackage, and you can search for any functions within that if you know the name, or you can also, this might be jumping a little bit, a head, but you can give it something like that, and it should return you anything that's string, etc. But anyway, you'd go into it and it'd give you a description of, you know, what the function does. Okay, we'll go a bit more because I'm jumping a little bit ahead. So in here, actually, if I go forward a little bit in here, so if we can go to the top, this is in base. Okay, so let's find we'll look for bind. Okay, this will do. Random. Okay, so you see here it says, this is another good tip when you're trying to install things. So in this scenario we looked for bind. Here we go. So bind is here, and we know it's in this library. So if you look at the top in the URL, it says network. But if you're not very sure what library it's in, at the very top on the top left here, it's a network, and that is what you would pop inside of this bit. So you just put network, for example. Okay, but for the beginning we won't need to do any of that. The next part is where your library is, you know, where the source file is. So we'll give it, ours is in here. Okay, and this is our executable. So you can imagine what happens is Stack is going to compile our program and create an executable from that then we can run. So things like JavaScript, you could imagine, you know, you're going to compile your JavaScript, whatever you happen to be using, and then what would run that program would be your browser. But in this instance, it makes it so, you know, you can run it from within here. But I'll show you an example of that in a minute. Okay, and then here's for the test, and then this tells you, you know, where you've got your test folder, etc. What you'll need to keep in mind is you can call your executable anything, and this is where you'd name that, and then it would run. Okay, so we've got things set up, but right now, you know, we've got all the parts that we want, but it's nothing's actually compiled at the moment. Okay, so what we want to do here is we're still in the same folder, and we'll do stack build. Oh no, we won't. First we'll go into the folder and then we'll do stack build. Okay, so what this is going to do, which is really great, is if you don't, it might take a bit longer for you, but what it will do, download the GHC compiler. I won't explain which one it gets right now because you know, it'll just go above your head, but let's not worry about that. It will download it, and it will download the packages, and all we've asked for is base, you know, which is what comes with all of Haskell. So we've got that, and then it will compile it. Okay, so now that we've done that, if we quickly have a little look at our code, here we go. So we get a file called lib, and we'll zoom in a little bit. So this is how you set up a file. So you have a module, you have to name that the same as the file itself. So you see it's lib.hs, we'd call that lib, and then what we're exporting between the brackets here would be this function. If you don't have this, it will export everything inside. Anything that's a function inside will be automatically exported. So if you want to have functions that are isolated just to that file, you wouldn't do this part here. But for this example, we'll do that. And then what we've got here is next we're declaring a function, and we're declaring its type. Okay, so this is a type. At the moment it's just an IO, and it's the value of unit. Okay, not worry about that for the yet. And what we'll do is we'll search for put string line, or put string line. Pop that in here. I'll search for it, and if we look, there it is. So it takes a string and it returns us an IO. Okay, so it's the same as put string adds a new line character. Okay, let's look at put string, and it goes writes a string to a standard output device. Okay, so that's interesting. So you can see it takes a string. We'll go back to the other one. There we go. It takes a string, gives us an IO. So if we look at the output of this, it's IO. So here's our function. It takes a string and it gives us an IO. Okay, so that's what it gives out. So that's the string we give it. So let's change that to, hey buddies, you know, we're learning Haskell. Okay, so we'll save that. And then if we look inside of main, we'll see inside of main we've got, again, I'll zoom in a little bit, we've got a module called main, and we import lib. There it is, we're importing it, and then we're running some func. So again, we give that a type, and we're saying it's IO. Again, just ignore that for a minute, because essentially at the moment IO is just saying, you know, what's going to be put out into our terminal. But I won't go into detail, let's just ignore that for a minute. I'll go more in depth later. And then we're calling some func. So if we go back to lib, some func should hopefully paste that out. Okay, so what we'll do is we'll do a stack build again. So it's building our program, and then we'll go look at our package.yaml, and we called it that. Because I'm lazy, I'm going to copy it, and I'm going to do stack exec, so execute, and then I've got it to there, that's my old one. Boom, there we go. Hey buddies, we're learning Haskell. Okay, so this is where you can definitely see. So hey buddies, we're really cool, honest. Okay, so we'll save that, we'll build it, and we'll execute it. Hey buddies, we're really cool, honest. Right, so you can see, I hope I spelled that wrong. Is that 2 N's or 1 N? Honest. Doesn't matter. It's going to be that for now. So what we've learned so far is to get Haskell quickly set up. We've looked at the files that Stack produces when we do a new project. And then, I should mention actually, is when you do a build, it will generate this StackWorks, which is what Stack uses to find out, you know, exactly what you've got installed. You'll never dip into here, but if we look, you see it shows you all the bits and pieces. That it essentially, it keeps everything of all your package management into us. It knows what versions work with what versions of which packages. And it keeps all that in isolation, which is really handy, as I've been burnt in the past where, you know, all certain versions don't work and do work. But anyway, so you've got this function, and then we've been able to build it by doing stack build, and then we've been able to execute it by doing stack exec, and then the name of our program, which was in the package. Now, if you're going around at the moment, you're sort of thinking, okay, well, this is all, you know, it's a bit sort of, it's going round and round a little bit. You know, every time I've got to do stack build to check my programs right. Well, there's an alternate solution to that. Is what you can do is use a program much like you do a watch. You know, you can just sort of watch files in JavaScript or something like that. There is a version of that. If you don't install some sort of a third-party package for your IDE, example, I've got one in this, but if you wanted to do it so it shows up in a terminal, then you've got a solution for that, and it's called GHCID. What this does is you basically install it, and here it is. For us, it'd be stack install GHCID, so I'll do that. Here we go, and now it's going to do that. Right, so we've installed that, and then how to use it is you run it from the root of your folder. So GHCID, and it will be running. Okay, so at the moment you can see the output is all good. So we know when we looked at put string, it expected a string, okay, and it gave us, you know, it's fine. But if we give it, say, a number, and I save it, boom, straight away we get an error. Okay, what I'll do is, as we go along, is sometimes the error messages can be a little bit confusing. But for this instance, it's just saying it's got an error. It's not got an instance of num string. Okay, which won't make any sense right now, but essentially it's expecting it to be a string, and we've given it a num. So if we go back, we'll save that, and then it's all good. And then if we, for example, change that to be an int, which is another type, we'll save it, and here we'll get a little bit of a better couldn't match the expected type int with the actual type IO unit. So it's saying, well, actually this gives us an IO unit, but what you're saying is I expect it to be an int. So where this comes in handy So if we put this back to IO, of unit, okay, and we'll save it again. So it's saying it's not able to match int with IO. Okay, so if we put this back to IO of unit, we'll save it. Okay, so it's saying all good. Now, here's a little thing called typed holes, and these are going to be really useful, because what we're going to do now is, when I first started, I always used to see all these compile errors. It's like, I'm just not getting it right, it's so annoying. But what you can actually do is use the compiler to help you write things. So here they are. Okay, this is really dead simple. So you just do underscore. Okay, so this is called a hole. Okay, so it's a type hole, and it's saying, okay, so I found a hole. The compiler tells I found a hole, and I expect that hole to be a string. Okay, so that's basically saying to us, put strings, expect, or put string line expects this value to be a string. Okay, so you can see here, look, I expect to be a string, and you expect in the so it expects it to be a string. So what you end up reading, I mean, there's a load of gibberish, and then later you'll find that also it will give you hints as to what you've got available in a specific function, what types they might be, and you can go from there. But it's super useful when you use type holes. If you're not sure about something, or you forget what type of specific function is, you can just do an underscore and it'll tell you what it expects to be. So we'll go back to hello like that, and that's all good. Okay, so you can see this just keeps running in the background, but if you have it in with your IDE, I can do here, and I can see down here I've got an error. If I do EL, there you go, I get exactly the same error down here as you do up there, but we'll run it from here. So like that, it's a little bit more accessible, because you might be using a different IDE, all sorts of things that might make it a little bit harder for you to get things going. Okay, so I'll put this back to a string like so, and now we're all good. I'll quit out of this. Okay, and what I'll show you now is the REPL. What I'll do is I'll get it going. So you type in stack REPL and press enter. It'll load up. So now what this is like a little interactive area where you can play around with your programs to see if things work. What you can do is test things, so we'll do some func. I've pressed tab there just to predetermine it will do that for you. Hello, you and me. Okay, so we can change that to you and you, for example, and we'll do :R, which is for reload, and that's reloaded it. And we'll do some func again, and it'll do hello, you and you. We can do another one, which is the type, so we can look at the type of some func, and that'll tell us that it's an IO unit. And then you can also :H will give you all the possible arguments. You can import specific modules or packages, which is really useful. And as I'll show you, it will run normal Haskell functions. There we go. I'll explain that in the future. So yeah, it's really handy, and if you want to quit, it's :Q. Okay, I'm going to put that back to the small size, and there we go. So I think what I've shown you so far is how to get set up, get going, have a little bit of a look around how things talk to each other, how the package YAML works, also GHTID, which is really great. I had like a little hint of doing the type holes, which is then using the compiler to sort of help you, what should this function take or shouldn't take. And then I showed you the REPL, where you can start experimenting and playing around with functions and seeing how they go together. And that's that for now. I mean, what we'll do next lesson is we'll look more into fundamentals of Haskell. Because I gave you like a little hint. I did a map, and what sort of output was that? That was a bit crazy. But what we can do is we'll go more in depth into that and how each of those types of things work. And especially, I think what we'll take a strong emphasis on is actual the types up here, because I had a long time sort of struggling against types. I think it's probably the best of words. I kind of ignored them as much as I could, because I concentrated more on, okay, well, what does this function do, and what does this function do versus its types. And I think if you sort of bring them both together and think of function and types as the same thing, it becomes a lot easier further down the line. Unfortunately, there's this misconception I feel within Haskell that the types is substantial. That'll do you a lot. So if you go, if we go check out, check out Stackage, and we look at that function we use, map, and there we go. It says A B B B B B, and you're just like, right, okay, well, what does that mean? And what's sort of lacking sometimes is improving is examples of these functions in use. Because sometimes you can just look at that and go, well, that doesn't make any sense really. It's just kind of like some stuff. But what we'll do is I'll explain types, what these arrows mean, and more in depth, so like that you've got a nice clear understanding of types themselves, which will then set you up into how functions work, because that's a big part. Just get the fundamentals of how you can sort of have functions talk to each other and what they expect as inputs and outputs. That whole concept is really useful to know before you get into the niggly bits, like the functors and the monads and all that sort of stuff. I think if we concentrate on how to use these functions, it's a lot more intuitive. Okay, well, thank you for joining me for lesson 1, and hopefully we'll come to lesson 2. Cheers, bye.